Lakshmi, Associate Professor from Panamalai Engineering College. I am going to explain a small topic presented in VLSI design subject. The title name is stick diagrams. So we all of us know why the stick diagram is needed. So stick diagram is a rough sketch which will give us a rough estimate about the chip size or area. So that is the purpose why we draw stick diagram before going to manufacture the chip. So stick diagrams are rough sketch that will give all the layer informations present in the circuit. So in a stick diagram is one step closer to the layout. So a stick diagram is a cartoon of the layout. Stick diagram gives us the stick diagram explains the rough estimation of the chip size. So stick diagrams does not provide the detailed information about the chip, which means it doesn't give the transistor size, which means W by L dimensions, width and length dimension of the transistor, and also it won't give the wire length and uh, boundaries and other details. So in stick diagram, we have to strictly follow the colors. We have to draw the stick diagram with the help of color pencils or color markers. So in stick diagram, we have predominantly used 5 colors. So the blue color is assigned for metal and red color is assigned for poly or gate layer. The green color is assigned for N diffusion. Then the yellow color is assigned for P diffusion and the black is assigned for contact points. So in stick diagram, the transistor should be represent like this. So the transistor should be represent like this. So if the dot point present in between the lines, it it does not consider as a transistor. It is considered as a contact. So here we have very clearly mentioned that this is N diffusion, that is NMOS transistor, and this is PMOS transistor. So in NMOS transistor, the diffusion is indicated by green color line. On the top of it, we have a metal layer which is represented with the help of the red color. So this is nothing but polysilicon or gate layer. Then and this is yellow color line. This yellow color line indicate the PMOS. On top over it, we have a gate, which is nothing but polysilicon material. The color used to represent the gate is red color. So the transistor should not be represent like this. We all very well know in static CMOS design, the bottom is our PDN network, that is pull down network. Then the top is PUN network, that is pull up network. The demarcation line is used to differentiate the PDN as well as PUN network. So this dotted line indicate it's a demarcation line which will help us to separate the PDN as well as PUN. So now we are going to draw the stick diagram for an CMOS inverter. So we all very well know this is the CMOS inverter. So in CMOS inverter, we have one NMOS as well as one PMOS. So the NMOS and PMOS both should be combined together, and the common input A is applied for both transistor NMOS as well as PMOS. As an inverter, only one input and one output. So bottom line is our ground line. This is nothing but VSS, and the top line is VDD. Then how to convert this static CMOS design into stick diagram? So students, listen carefully. See, on the top of it we have a VDD line, that is supply line. So the supply line is indicated with the color blue. Similarly, the ground line is indicated with the color blue. Then the top we have PUN, pull up network. So the pull up network is consist of only PMOS. So the P diffusion is indicated by yellow color line. So transistor, how to represent transistor? So the transistor is represent like this, like cross symbol or plus symbol. So the first line, the bottom line indicate the diffusion, the top line indicate the gate. So one PMOS transistor and the other one is NMOS transistor. In NMOS transistor, the diffusion is indicated, the N diffusion is indicated with the color of green. On the top over it, we have a gate layer, gate. So the gate is represented with the help of the red color. So the gate, the polysilicon or gate, both the gate of our PMOS and NMOS are connected together and the common input is applied. Then on the PMOS and NMOS, to connect PMOS and NMOS, we need a metal wire. So metal wire indicated by blue color. Then the demarcation line, this line separate the PMOS as well as NMOS. So here we can take the output. Then the very important thing, we have to label it. So the top line is supply rail. This is labeled as VDD. The bottom line is ground line. This is labeled as VSS. Then whenever two different medium or material touches with each other, we have to mark a contact point. So here this is metal line, that is supply wire, then diffusion. So two different medium touches together, so make a contact. Similarly, this is P diffusion, and then the another one is N diffusion. So the P diffusion and N diffusion both cannot be joined together because both are different. So we need a metal wire to different or to separate the P diffusion as well as the N diffusion. So this P diffusion touches the metal wire, so we need a contact. Similarly, metal wire and N diffusion are going to touch with each other, so we need a contact point. Similarly, our N diffusion and the ground line is going to touch each other. So again, we need one more contact point. So we need totally 4 contact points to represent one static CMOS inverter. Hope this is very clear to all. See here, then what is the name of the circuit? Here the transistor, the NMOS transistor A and B are going to be connected in series. So it is A dot B. So it is a CMOS technology. So the output is the complement of this. So A dot B whole bar. This is the CMOS static circuit of NAND gate. So now we are going to discuss about how this CMOS circuit is going to be converted into stick diagram. So here A and B both are the NMOS transistor, both are connected in series. So here this N diffusion, but two transistors. So this is transistor 1 and this is transistor 2. Similarly, on the top, the same A and B, we are having here. So this is PMOS 1 and this is PMOS 2. So PMOS, to represent PMOS, we need a yellow color. So this yellow color represents the P diffusion. Here the green color represents the N diffusion. Okay, so then on the top here, the A and B both are connected in parallel. So we have to make a connection like this. So this transistor, see guys, listen. So this transistor and this transistor both are going to be connected in parallel. Okay, then this is our PUN network, and PUN, on the top of the PUN network we have a supply rail. For supply rail we have to use the blue color for indication. Then the diffusion and the metal line both are going to touches with each other, so we need to make one contact point. Similarly, the diffusion and the metal line, so we have to make the another contact point. This is P diffusion, and whereas this is N diffusion. So to separate the P diffusion and N diffusion, we need a metal wire. So the metal wire, again it is blue color. Then the metal wire and the N diffusion, again we need one contact point. So here A and B are connected in series. So the transistor A and B are connected in series. Okay, so the two transistors are combined together and apply the input A, and the input B is applied to one NMOS and the another PMOS. Then the output is going to be taken in between. What is this? This is PDN and this is PUN. So the output is going to be taken in between PDN and PUN. So this is the static NAND gate stick diagram design. Hope you guys understand the concept clearly. So if you have any query, you please write in a comment. So definitely I will see your query and I will answer you. Thank you so much, students. Thank you.